Okay, in this part here, right, I'm going to show you or prove to you the formula for you to find area of a rectilinear figure. Okay, example is a triangle. Okay, so I'm going to present to you
What's a
the
rectilinear figure?
rectangle, square, polygon, etc.
Oh,
Okay, applies to polygon also. Rectilinear figure, rectangle, square, all kind of figure except circle. Except for circle and oval. So circle and oval, that one is next chapter.
long as they have vertices.
Yeah. So long they give you the vertices, right? The coordinates of the vertices, right? You can find area of this triangle using the formula. So before we use the formula, I'm going to prove to you, right, how this formula is derived. So right now here we have a triangle, right? PQR. Okay, we have a triangle PQR. The triangle PQR, the coordinates of P is x1, y1. The coordinates of Q is x2, y2. Coordinates of R is x3, y3. So this is not a right angle triangle. This is not a right angle. So it's just a random triangle. Okay. So the length of this part here, right, will be y2. Because the coordinates of Q is y2. The y coordinates of Q is y2. So the length of this is y2. Likewise, this is y1. Because the coordinates of P is y1, so this length is y1. So here is y3. And how about here? The length of AB, right, is x1 minus x2. x1 minus x2, you have length of AB. x3 minus x1, you have length of BC. And length of AC will be x3 minus x2. Okay, so you clear how we get all this length, right? So to find the area of this triangle PQR, right, is apparently the area of this big triangle here, not triangle, this big polygon here, quadrilateral here, called PACR minus area of this trapezium AQRC. Oh, you agree? So area of triangle okay, area of trapezium AQPRC, area of figure AQPRC minus area of trapezium AQRC. Oh, you agree, this one? So area of APQRC, right, would be area of this trapezium AQPB plus area BPRC minus area of AQRC. This part you understand, no?
yeah.
Oh. So area of AQPB, right? AQPB is the area of trapezium, right? Area of trapezium is y2 plus half y2 plus y1 times x1 minus x2. Okay, this is area of AQPB. So this part, half A plus B times H plus half BPRC half Y1 plus Y3 times your x3 minus x1. Then minus AQRC, right? Minus half Y2 plus Y3 times your x3 minus x2. Okay. Understand how I get this?
Yeah.
Can you can check AQPB will be half A plus B times H.
Yeah.
Half A plus B times your H. Then the
Okay.
other one is this one.
BPRC.
Yeah. BPRC will be half Y1 plus Y3 times x3 minus x1. Okay. Then this one will be, you take out, this one will be half Y2 plus Y3. Okay. Multiplied by this x3 minus x2.
So you can find PQR.
Yes, this area. So basically it's area of this whole chunk minus area of this.
Oh.
Then area of this whole chunk is area of this plus area of this, then minus this part. Okay. Then after that, you take out your half. If I take out my half, then this part, if I expand, this is my x1, y2. X1, y2 minus x2, y2 x1, y2 minus x2, y2 plus x1, y1 minus x2, y1. Okay. And plus this guy here, right? Because I take out my half already. Right? So plus this guy will be x3, y1 x3, y1 minus x1, y1 okay, then plus x3, y3 minus x1, y3. Okay, minus x1, y3. They don't have. Okay, here they take out minus, so there's a minus sign here. So the first one is minus x3, y2. Minus x3, y2 plus x2, y2. Because there's a minus sign here, I need to take out the half, I need to take out minus half. So I have x3, y2 plus x2, y2 minus x3, y3 and plus x2, y3. Oh, you have this. Then if you notice, or you can simplify x1, y2. Where is my x1, y2? Okay, x1, y2 still alive. x2, y2. x2, y2 disappear. Oh, x1, y1. x1, y1 also disappear. Oh, x2, y1 minus x2, y1. x2, y1 still alive. How about x3, y1? Okay, x3, y1 still alive also. Then x3, y3. x3, y3 disappear. Oh, plus x3, y3 minus x3, y3 disappear. How about x1, y3? Okay, x1, y3 still alive. And minus x3, y2. Okay, why x3, y2 still alive? And plus x2, y3. Can understand, no? So far you can understand?
A bit struggling.
Huh?
A bit struggling. Okay.
You understand? Basically, it's just the terms can cancel off. Oh.
Oh.
When I expand this, I cancel off. Oh. Because it's
Oh.
simple, minus and plus is disappear.
Oh.
Okay? This is plus x1, y1 minus x1, y1, so it disappear. Then
Oh.
x2, y2, right? x2, y2 it disappear. Minus and plus neutralize. No? Then x3, y3, x3, y3 it disappear also. Oh, understand? No? So these are the residual terms now. Okay? So the residual terms, you're going to rearrange, right? x1, y2. x1, y2 plus x2, y3 plus x2, y3 plus x3, y1. Because there are three negative terms and three positive terms. Can you see? Minus x2, y1 minus x2, y1 x3, y2 and plus your x1, y3. Okay, this is the formula, right? That you are so-called supposed to memorize, but you don't have to memorize this because if you notice, your x1, x2, x3, right, is actually your, let's say I rearrange, right, my PQR, right? Let's say I rearrange it in this way on half. Okay. half x, I arrange this way. Oh, you understand this part? If I arrange this way, you can get back this. Okay, you want to see, I show you how I get back this from this. This arrangement will be easier to remember. Right? It's anti-clockwise. X1, Y1, X2, X2, Y2, X3, Y3, X3, Y3, X1, Y1. So it's anti-clockwise direction. You just remember the coordinates, then arrange in anti-clockwise direction. Then the starting point is also the ending point. Okay. Once you have this all, okay, I multiply the negative side first. So x1, y2, x1, y2. Negative gradient first, plus x2, y3, plus x2, y3. Can you see that?
So I can actually write like the two straight lines during the.
You write like this in exam, so that you don't have to memorize this, because this one is very hard to memorize.
Oh, okay.
That's why they come out with this, so that it's easier to remember this formula. So I'm trying to prove to you the formula.
Okay.
So I proved to you the formula already, right? From here. In the end, I end up with this law. Now I just need to prove to you this is this law. Then you can use this law. So x1, y2, x2, y3, x3, y1. Oh. Okay. x3, y1. Then minus the positive gradient x2, y1 plus y3, x3, y2 plus x1, y3. Okay. Okay. You got this also. You notice? Can you see?
Oh, okay.
x2, y1, x3, y2, x1, y3. Okay. So it's half. You remember there's a half. Then negative gradient. Negative gradient. Negative gradient. I know what I mean by negative gradient. X1, y2. Addition of all the negative gradient minus addition of all the positive gradient. Then this side first. You time this side first minus this side. Understand?
Oh.
You need to remember is this side first. So
Okay.
negative gradient. This side is negative gradient. So negative gradient first minus positive gradient. Understand?
Oh.
Okay, like this easier to remember than this, right?
Yeah.
Then you can get this off. So you can apply the formula. This is a formula. You just arrange the coordinates in anti-clockwise direction. And where you start is where you stop. You can start from here. Start from here. So where you start is where you stop. So you choose a coordinate where there's 0 to put it as the first and the last coordinate. You know what I mean? So that you multiply, if it's 0, right, this thing disappears. Then you got less thing to bother. You understand what I'm saying?
Yeah.
Because you can arrange the coordinates, you can choose Q, R, P, or R, P, Q, or P, Q, R, whichever sequence. You can choose which one go first. But the whichever that go first must be the last one. First and the last. Now understand now. So
Okay.
this is how you find area of this triangle. Then you simplify this part, you'll get the area of triangle already. This kind of question, student very prone to make careless mistake. So you must be very careful. Okay, any question?
Okay.
You have any question?
No.
If no question, we go to the questions already in the book.
Uh,
Okay.
yeah.
Okay.